We're going to do a quick review on parent function and transformations. If you know your parent functions and your transformations, what we're about to do next will be really easy. So what do they look like? This is what they look like. X squared, x cubed. We're going to work out the square root of x and the cube root. And exponential should look like a b to the power of x. All right, so let's go ahead and actually work this out. So if I didn't know what it looks like, here's a way that you could know what it looks like. You just plug in the numbers. So what's the square root of -9? I can't do it. It's undefined. The square root of -4, it's undefined. Any square root of a negative is undefined. Square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Go ahead and plot those coordinates. So you can't plot the undefined. 0, 0, 1, 1, 4, 2, and 9, 3. So what does that graph look like? What does the square root of x look like? The parent graph looks like that. We're going to do the same thing for cube root. I'm going to use a calculator. If you don't know how to put cube root in the calculator, you can transform it to x to the power of 1/3. So I'm just going to put in the coordinates. So if x is -9 and I cube root it, the same as saying a power to 1/3, you're going to get -2.1. Okay, so we're going to just round it. I'm going to change the -9 to a -4, and I'm going to get -1.6. I'm going to change the -4 to a -1, and I'm going to get -1. I'm going to change the -1 to 0. So I'm just, when I input the x, what output do I get? And then you just fill in the table. So cube root of 1 is 1. Cube root of 4 is 1.6 rounded. Cube root of 9 is 2.1 rounded. All right, so all you got to do is plot those points. So plot the first point, -9, -2, -4, -1.6. Just an approximation is fine. -1, -1, 0, 0, 4, 1.6, 9, 2.5. And just an approximation is okay. All right, go ahead and join those dots and extend the line in both directions. And this is what the cube root of x looks like. So it looks like an S stretched out in both directions. Okay, this is what an exponential looks like. Once you understand what the parent graphs look like, so for example, a parent graph for linear would be 2x plus 3. So the parent graph is y equals x. The parent graph for x squared will be x minus 2 squared. So you can see anything squared, the parent graph is x squared. Anything cubed, no matter what numbers they put everywhere, is the cubed parent graph, and so forth. Okay, so once you know that, you can do any kind of transformation to it. So let me explain transformations to you so that you can understand how to do it. So you have -a minus b plus or minus c plus or minus d. If you know your ABCs, you're fine. All right, so I'm just going to use a highlighter. Adding and subtracting is a shift on the x or y axis. So adding or subtracting, those are the two, are shifts. Okay. Multiplication is a stretch or shrink in the x or y. So anything multiplied. So that's a and b. If you have numbers there, that's multiplication. Stretching or shrinking. Negatives, and this is not a minus sign, these are negatives, are flips over the x and y axis. All right, so let me go over the rules. If it's inside the parentheses, it's x and opposite. So if this is it, if you have plus c, you think to go right, but you go left. If you have minus c, you think to go left, but you go right because it's opposite. Outside the parentheses is y and regular, meaning it's the y-axis and exactly what you think it's going to do. So d is outside. If it's positive d, it goes up. If it's negative, it goes down. Finally, a negative is opposite no matter where it is. So if it's inside, you'd think it's x, but it's really y. If it's outside, you would think it's y, but it's really x. So pause the video, copy those examples down. The very first box you're going to ask yourself is this: is it inside or is it outside? So look at this example. It's outside, so it's y and it's regular. What does plus 5 do? It's going to be adding, so it's a shift in the y direction because it's y and regular. So you're adding 5, so think of the y-axis. It's going to go up 5. All right, this is inside the parentheses, so it's x and opposite. Inside the parentheses, x and opposite. What does plus 3 do? So it's a shift in the x direction, opposite of what you think. So plus 3, you think goes right, but it really goes left because it is opposite. All right, what do we have here? We have something inside, so that's x and opposite. We have something outside, that's y and regular. So let's do x and opposite first. What does plus 1 do? In the x-axis, you think it goes right, but remember it's opposite, so it goes left. On the y-axis, it's y and regular, so it's exactly what you think. So what does minus 7 do? It goes down 7. All right, so is it inside or outside? That's outside, right? So outside is y and regular. Then we've got another one that's outside, y and regular. But remember, negatives are the only one that are opposite no matter what. So it's going to be opposite. I would think it's y because it's outside, but it's going to be opposite, which means it has to be x. So this is going to be a flip over the x. This is what you think, y and regular. So y-axis, is that going to go up or down? It's going to go down because it's -2. One final example. What is that? Is that inside or outside? It's outside, so it's y and regular. And what does a third do? What does a fraction of a multiplication do? So multiplication is a stretch or shrink. So think about it for a second. If you multiply it by a fraction that's less than 1, it's going to make the number smaller, so shrink. If you multiply by a fraction greater than 1 or a number greater than 1, it's going to make a stretch. So because it's y and regular, it's a y-axis, and it's what you think. So a third is less than 1, so you think shrink in the y direction. Again, the only way you get good at this is practice, so let's practice.